Hello, my name is Talaver and I'm presenting the topic of dynamic system analysis using telemetry. Usage of distributed solutions though facilitates scalability and ease of development, especially when it comes to companies with large number of developers, brings difficulties faced by those developers like complexity of understanding the entire system and observability. This poses the need for more intelligent tooling that will facilitate analysis of such a complex system. Let's firstly review a few approaches to analyzing distributed systems. One is being a static analysis of a code base of each component, and also other possible is analysis of system's event log. Both options are quite complicated because you need to adapt to specific languages and platforms, but also is not quite accurate. Instead, in recent years, research of telemetry application is gaining traction because it provides much more accurate runtime information that the already mentioned methods can provide. But what is telemetry? Telemetry is a set of so-called golden metrics of a system, which are logs, metrics, and traces collected during system operation. The development of this direction of research began as early as 2010 with the article published by Google called DAPR, a large-scale distributed systems tracing infrastructure. Over time, three standards were released. OpenTelemetry is the last of them, which has been under development for the last 4 years. In order to highlight specific problems for further research, a list of the most popular applications was reviewed, which is not exhaustive but includes all important aspects that can be found in other systems. A basic set of capabilities includes review of metrics, requests, visualization of those, and filtering. The key features are related to aggregation of those and further analysis, of course. A couple of topics were chosen. Since the entire system consists of groups of components that are developed by different teams, it is very difficult to analyze the entire system. So subtle problems, also called architectural smells, can creep into the structure and increase the development efforts. In addition, in such a huge system, it is too difficult to identify and react in advance to anomalous events like deterioration of a service performance, because you would need to manually watch lots of graphs. For this reason, the automation of those tasks is a relevant topic. To analyze bad architectural practices, firstly, we need to build an actual model of a system. For this, the Neo4j graph database is used, which physically stores the graph and makes it possible to use graph theory for analysis. Two types of entries are present, resources and operations. Resources can provide operations or they can call them. To collect telemetry, it is recommended to use OpenTelemetry Collector, which is an application for collecting telemetry from the system, transforming it and exporting to other systems, databases. There are quite a few ready-made integration modules, for example, for Prometheus. This project uses a custom component that extracts information about the number of calls, presence of errors, and the latency of those calls. Let's now talk about anomalous detection. It is actually a common task in software development, especially when it comes to analyzing many variables at the same time, for example, metrics of several services. And anomaly is defined as a difference between expected value and reality that exceeds certain threshold, right? Um, Unsupervised PCA algorithm was chosen because it is difficult to get labeled data, and all unsupervised algorithms do not have statistical difference, so the simpler the better. Before analyzing the data, it has to be properly formatted. The collector component uses modules to extract the key metrics and group them, and the information includes service names, number of calls, timestamps, presence of errors, and whether the requests are synchronous or asynchronous. Later, these metrics are processed to bring them to the time series format. For the sake of testing and demonstration, OpenTelemetry Demo project was used. It is a system specifically created for the development of tools working with telemetry. It consists of many services in different languages with different communication protocols. On the picture, a graph can be seen where nodes depict the services and arrows dependencies between them. The visualization is done using Neo4j Bloom solution that just modifies graph to show some algorithm relation. In this case, size show importance of particular service and color cluster that it belongs to. The result demonstrate the possibility of using this analytical approach for dynamic analysis of a medium system, as we clearly see where the bottleneck services are and what groups of those are too tightly coupled. To analyze for the presence of anomalies, a time period of several hours was chosen, which was divided into parts and analyzed. On the picture you can see two charts where the upper one shows relative prediction error for the whole system and the bottom for individual features. As a result, we can clearly see a presence of some anomalous situation for particular feature, and of course the threshold for the error should be set dynamically. As a conclusion, the use of telemetry for system analysis has a great chance for further development. In the case of architectural smells, it is possible to analyze the problem of long chains of synchronous requests, detect slow ones, the belonging of services to a certain mode and context. As for the anomalies, it should take place in a certain time window of sufficient size to avoid the influence of seasonal changes. For example, the difference between activity at night and during the day, or at a certain time of a day, for example. In addition, all collected information should be displayed on a system map for quick access and functionality tested on a real production system.